Python counting number of presence and absence of substrings in list of sequences. You can get the data here. 2 shared the bottom download. I'm analyzing biological data with Python. I've written down a code to find matching substrings within a list of lists of long strings. The substrings are in a list and have length of 7 nucleotides. So in the list, from AAAA to TTTTTTT, 16,384 motifs, substrings, are present, permutating A, C, G, T. This code has a for loop for the list of substrings and the list of lists of long strings nested inside. It works okay, but because of the list of lists with 12,000 lines, the code processes very slowly. In other words, to give info about AAAA and to the next, which is AAAC, takes 2 minutes. So it will take 16,384 motifs to go through 12,000 lines for 2 minutes. It will take 16,384 times 2 equals 32,768 minute, 546 hours, 22 days. I'm using scipy and numpy to get values. What I want to is counting number of presence and absence of substrings in list of sequences. The list of long strings and the code are like this. Is there any easier method without implementing any other things? I think the iteration for pattern match is the problem. What I'm trying to find is both how many times a length 7 motif occurs in the whole list of sequences and not occurs also. So if a motif is present in a string, which is true as bool, then increment a value in false, then increment an other value. Not the number of motifs within a string.
Excellent question. This is a classic computer science problem. Yes, there is indeed a better algorithm. Yours processes each long string 16,384 times. A better way is to process each long string only once. Rather than searching for each motif within each long string, instead you should just record which motifs appear in each long string. For example, if you were searching for length 2 motifs in the following string, then you could run a loop over the length 2 substrings and record which ones are present in a dict. Now you've processed the entire string exactly once and found all the motifs present in it. In this case, the resulting dict would look like. Doing something similar for your case should cut down your runtime by exactly 16,384-fold.
There are several odd things about your code. What you are calling permutations looks more like the Cartesian product, which can be computed using itertools.product. Because Python is zero-indexed, the first element of a string is at index 0, and so the comparison like I2.find smotif is lower than 1 will return true if the string is there right at the start, which seems a little odd. Your odds ratio, value and enrichment calculations are inside the loop, but neither the zeroing of the counts nor the print is, which means you are computing them cumulatively for each new row but not doing anything with that information. You recompute I2.find smotif multiple times in the typical case. That result isn't cached. Assuming that I understand the numbers you are trying to compute, and I could well be wrong, because there are several things you are doing that I don't understand, I'd flip the logic. Instead of looping over each motif and trying to count it in each row, loop over each row and see what's there. That will be roughly 7 asterisk the number of rows instead of the number of motifs asterisk the number of rows. For example, I lowered the line length just to make the output faster. If the line is 10 times longer, the code takes 10 times as long. This produces on my slow laptop, after inserting some line breaks. So I'd figure about 20 minutes for the full problem, which isn't bad for so little code. We could speed up the motifs_not_scene part by doing the arithmetic instead, but that would only get us a factor of 2 anyway. On a much smaller case, where it's easier to see the output.
Basically, your problem is sequence comparison. Finding motif in sequence is a fundamental question in bioinformatics. I think you could search for some existed algo or packages. I searched the keywords motif match in Google, and this is what I found in first page. This URL. This URL. This URL. This URL.
A clean and very fast way, tilde15s with ARPS data, would be to use the count vectorizer of scikit-learn as it uses numpy under the hood, for example. Now X is a sparse matrix having all possible chunks as columns and sequence as rows, where every value is the number of occurrences of the given chunk in each sequence. Now you can sum along the columns, mask non-values, or whatever manipulation you need to do, for example. Finally, to find how many occurrences a given motif has, you must find the index of the corresponding motif chunk and then evaluate in the previous sum. In your case, you would have to divide your list in two parts, positive and negative values, in order to include the down condition. I made a quick test with the list from DSM's answer, and it takes around 3 to 4 seconds in my computer to run. If I use 12,000 length 4,000 sequences, then it takes a little less than a minute. Edit: the whole code using ARPS data can be found here.
If you want to support the channel, please consider liking and subscribing.